All right, here's this other one that you asked about. These are a little bit more of a pain because they're a little bit long to do. But I'm actually, for the first line, I'm going to use the method that I started doing in the last problem that didn't actually work that well. I feel like the quickest way to graph this one is to make a little table where you plug in 0 for x and you solve for y. So y is 2. And then plug in 0 for y and solve for x. So x is 2. And then as long as you have 2 points, 0, 2, and 2, 0, then you can draw a line through those 2 points. You pretend like all of these are equations, not inequalities. So we're going to ignore anything about the shading or anything like that until later. So there's my first equation. It actually turns out the slope is -1. So I find the more exact I can be when I graph these, the better. So I think even though I don't need to, I'm going to draw a whole bunch of dots just in case that helps. The next equation, I'm going to call it, even though it's really an inequality, I feel like maybe it would be best to divide everything by 4 and get y. I'm just going to replace it with an equal sign. Y equals 1/4 x plus 2 and graph that line. So y-intercept of 2, and then I'm going to go up 1/4 a couple times. Maybe I'll even go down and to the left. Also to try to get a decent line. And then luckily this last one's already in slope-intercept form. So y-intercept of -5 and a slope that goes up 2 over 1. So there's all of my equations. Where the inequality comes in is which direction you shade. So I'm going to start with the first line, which is the red line. As long as the line doesn't go through 0, 0, I plug that in to check and see which way I should shade. In this case, 0, 0 is here below the line. So I'm going to plug in 0 plus 0 is greater than or equal to 2. 0 is greater than or equal to 2. That's false. So I don't want to shade toward the 0, 0. I want to shade away from 0, 0. Okay, now I'm going to try the green one. I'm going to plug in 0, 0 also, which is to the left of the green line. So that would be 0 is less than or equal to 0 plus 8. And that is true. So I want to shade toward the 0, 0, which is to the left. And then finally, I'm going to do the blue one and plug in 0, 0, which is below the blue line. So 0 is greater than or equal to 0 minus 5. 0 is greater than or equal to -5 is true. So I want to shade toward 0, 0, which is below the line. And then the shaded region is the places where all those different shadings intersect, which is inside this little triangle here. So that's the feasible region. It looks like the coordinates. My computer is about to die, so I'm going to plug it in to make sure that it doesn't. I think that the coordinates of the vertices of that triangle look like they are 0, 2. It looks like 3, 4, but I should probably check and make sure that actually lies on both of those lines. No, that's not true. 4, 3, it looks like. Let's see, if I plug that into this green line, 2 times 4 minus 5 is 3, so that works. And then the blue one, 4, 3. So 4 times 3 is 12. And then 4 plus 8 is also 12, so that is true. So 4, 3 lies on both of those lines, and then it looks like 2, 0. Looks like this final vertex over here. So those are the vertices of the feasible region, which is the shaded region. And then it says find the maximum and minimum values for the function. So it's this function. So you find f of 0, 2, you find f of 4, 3, and you find f of 2, 0. So I'm going to plug in 4 times 0 plus 3 times 2. Then I'm going to plug in 4 times 4 plus 3 times 3. And then I'm going to plug in 4 times 2 plus 3 times 0. And then it looks like I want the maximum and I want the minimum. So 0 plus 6, 16 plus 9, and 8 plus 0. So it looks like the minimum is 6. The maximum is 25. The minimum is 6 at 0, 2. The maximum is 25 at 4, 3. So sometimes it asks for like what's the best solution. So sometimes it asks for the 0, 2. Sometimes it asks for the 6. It looks like it asks for the minimum value of the function. So I think they're looking for the 6. The maximum value of the function, I think they're looking for the 25. So hopefully that helps. That's a long one. Let me know if you have any questions.